In this video, I used the purchase of Manhattan Island as an example for the power of compounding. So the legend says in 1626, the settlers purchased Manhattan Island from the local Indians by $24. That number is back to the 1860s. So in today's term, it's about $1,000. I find this information from Wikipedia. And let's look at the land price. With this $1,000, the settlers purchased about 23 square miles from the local Indians. 1 square mile is about 28 million square feet. So the total square feet is, you use this 23 square miles times this 28 million, you got this 640 million number. Now, then we can see you use this 1,000 divided by this 640 million, you will get this teeny tiny number, much less than a penny, right? And this a penny, less than a penny amount of money. In 2007, what's the land price? The land price in 2007, I find a code from the internet. The price of a buildable square foot in Manhattan Island in 2007 is $500. So it takes about 382 years to grow this teeny tiny number, much less than a penny, to $500. Okay, and let's see how much it growed. Let's use 500 divided by this guy. It's grown by 320 million times. 320 million times. Okay, let's see. 320 million times. How does that happen? Using the solver in Excel, I find out this growth rate. So let's, this is the price. Okay, what I did here is I take the difference between the future value to the price in 1626 to the current price now, $500, right? And with this growth rate, or the interest rate, compounding interest rate, I can grow this blue number, teeny tiny blue number here, okay, to this $500 here. And how does that happen? I just calculate the compounded future value, right? Again, blue number times 1 plus this interest rate, about 5.26%, and then you compound it, right, with 382 years to year 2007. You got $500. Again, that means I grow my money by 320 million times. Okay, that was the price back to the housing boom in 2007. The stock market was still high, and the subprime crisis just started. The recession hasn't got here yet. Okay, let's say in 2010. Okay, the price fell to $400. Now I got a difference. So here I want to demonstrate how you can use the solver to get this growth rate. Okay, now let's use tools. You got solver from the tools. Here's it. Okay, and the target cell is this one. You want it to be 0 so that your future value here and this price will be 0. Okay, and let's close that because I want to change this one to 2010. Okay, 2010. The time passed here is exactly how it calculated by Excel. Okay, it's 2010 minus this 1626. I want that year also count in, so I plot +1 to it. So it's 385 years. Okay. Now, again, you go to Tools, get a solver. If you don't see it in the Tools, you use add-ins to get it into the Tools. Okay, you want to change this target cell to the value of 0 here. Okay, so that my future value and the current price is the same. And then I ask Excel to guess a number for my interest rate here, so that I can get a future value exactly equal to $400, or say I get my target cell equals 0. So I click solve here, and I will keep my solver solution, and you can see the interest rate only decreased by 10 basis points to 5.16%, and then I got this $400 future value. Again, let's look at that, how much that growth is divided by this historical price. It's still about 256 million times. Okay, so with a moderate interest rate, give you enough time, about 400 years, you can grow a teeny tiny number to a gigantic number. If you think about that, right, start to saving now, and by the time you retire, probably you will have a very handful of savings to spend for the rest of your life.